Hey everybody! Are you interested in the concepts of chemical equilibrium, equilibrium constants and shifts in equilibrium? Nice! Then let's go to work with these calculations and the law of mass action. First of all, let's have a step-by-step look at how the equilibrium constant Kc is actually calculated. You don't even know what an equilibrium constant is? No problem, just have a look at this video first. Great! Well now, as an opening question, what can we actually express with the Kc value? Or rather, why is it so important for an equilibrium reaction? Do you still remember this slide? It'll give you the ultimate answer. With the Kc value, you can make statements about the concentrations of the reactants and products in an equilibrium reaction. So, you can determine the shift in equilibrium. Well then, let's have a look now at how this value is calculated. Basically, to calculate the Kc value, you need to find the quotient of the product of the concentration of the reaction products divided by the product of the concentration of the reactants. So to speak, K forward divided by K reverse. When we write out the whole thing, we get the following formula. Here, the lowercase c stands for the concentration of products and reactants. This formula, used to calculate Kc, is also known as the law of mass action and is always pretty damn important in chemistry lessons. In general, the equilibrium reaction is described as follows: A times A plus B times B to C times C plus D times D. The lowercase letters here represent the stoichiometric factors. These are the numbers found in front of a reactant. For example, if sulfur is used 3 times for the reactant AA, the lowercase letter will be designated by a stoichiometric number of 3. But let's calculate it using yet another example to make it easier to understand. For this general equation, the law of mass action is given by the following formula. Kc equals concentration of C with exponent C times concentration of D with exponent D divided by concentration of A with exponent A times concentration of B with exponent B. You've really got to know this formula to do the calculation. We'd better work through an example. Let's look at the equilibrium reaction of hydrogen and iodine to hydrogen iodide. At a certain temperature, you obtain a concentration of 3.5 moles per liter of hydrogen iodide. This 3.5 moles per liter is our concentration of the product. The starting substances, that is, the reactants iodine and hydrogen, are each present in concentrations of 0.5 moles per liter. In order to find out the equilibrium constant Kc, and know in which direction the equilibrium is going to shift, we'll insert the values into the law of mass action. And do you also know why the number 2 in the numerator is written as an exponent? Exactly! Because there are 2 hydrogen iodide molecules on the product side. Put it all in the calculator and we get 49 as the value of Kc. So we have a value greater than 1 for the equilibrium constant Kc. So the equilibrium shifts to the product side. Pretty easy, innit? Alright, so what was important here? Whatever the case, you've got to know the general formula for calculating equilibrium constants. That's definitely the foundation. And then, when inserting the numbers, always check if there are any stoichiometric factors. These are then added as exponents in the equation. If you can focus on getting these things done, then you're totally gonna rock these calculations. And with that, have an awesome day and go for it!